Hi, I'm Clara Moyano. I'm the materials engineer at Parker Hannifin Instrumentation Products Europe, and I'm here today to talk about 316 and 6MO. Many customers are facing material challenges nowadays. The oil and gas industry in particular has evolved enormously in the last decades, operating now in harsher environments than ever, with more stringent regulations and performance expectancy, in a genuine need to deliver cost effectiveness and trouble-free operations in order to be competitive. A prime example of that are all those applications where 316 stainless steel was a material of choice 20 years ago, but not anymore. Corrosion failures, sometimes in a matter of months, have made many end users to move from the standard 316 grade to a more advanced material called 6MO or 6molybdenum. But what are these two grades and why are they different? Both 316 and 6MO belong to the same family of alloys, the austenitic stainless steels, very well known for their excellent balance between mechanical properties and corrosion performance. By increasing the levels of molybdenum, or MO, we significantly improve the resistance to pitting, crevice and microbial corrosion. The higher chromium content, or Cr, increases the resistance to general corrosion, and the increased nitrogen content, or N, improves the mechanical strength of the material as well as the pitting and crevice corrosion resistance. Additionally, the copper traces, only present on 6MO, increases the resistance to some acid attack. Here is a comparative of corrosion performance indicators. The first indicator is called PREN, or pitting resistance equivalent number, and is an indicator of the capability of an alloy to resist pitting, which is a form of localized attack. The higher the PREN number is, the more resistant the alloy is to pitting. As we can see here, the performance of 6MO is far superior to that of 316. The third indicator on this table is called the CCT, or critical crevice temperature. This is again another value that we calculate experimentally by following standardized procedures and tell us the minimum temperature at which a given alloy is likely to suffer from crevice corrosion. As we can see here, once more, 6MO is far superior to 316. Moreover, stress corrosion cracking testing conducted on both alloys showed that 6MO is likely to last 3 times longer than 316 when exposed to a corrosive environment. In mechanical terms, 6MO is also superior to 316 by 50% approximately. Also, 6MO offers excellent welding properties. The use of 6MO has increased dramatically in the last decades, and this has permitted an availability as good as that of 316 and lead times nearly identical. 6moly is available in every form, including tubing, and its intentional chemistry permits stainless steel to be a cost-effective alternative to more expensive nickel alloys. Although the oil and gas industry remains one of the main users of this alloy, 6MO has been extensively used and successfully documented in a wide variety of demanding applications. Parker has been offering this alloy for the last 4 decades, and its usage continuing growing year after year due to its versatility and cost effectiveness. With decades of experience and thousands of successful applications out there, Parker is here to help.